Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Today we'll discuss derivatives. We define the derivative of a function at a point a comma f of a to be the limit as h goes to 0 of f of a plus h minus f of a over h. We can recognize the expression to the right of the limit as the slope of the secant line from x equals a to x equals a plus h. As h goes to 0, the expression becomes the slope of the tangent line. So the derivative of the function is simply the slope of the tangent line if that limit exists. For a function in general, instead of at a point a, we can consider any x value, and we find that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. So the derivative is really just the slope of the tangent line, and as we've discussed earlier, that's simply the instantaneous rate of change of the curve. There are numerous notations for derivative: f prime of x, y prime of x, dy dx, df dx, d dx of f of x, and d of f of x. These all mean the same thing, the derivative of the function f of x. We define the term differentiable in the following way. A function f is differentiable at a point a if f prime of a exists. So if the derivative exists at a point, we say the function is differentiable at that point. If the function is differentiable on an entire open interval, we say the function is differentiable on the interval. One theorem that results from our definition of the derivative is that if a function is differentiable at a point x equal a, then it must be continuous at x equal a. And there's a simple proof of this. If the function is differentiable, that means the derivative exists. If the derivative exists, well, here we have the definition of the derivative. The limit as x goes to a of f of x minus f of a over x minus a. That if this quotient has a limit as x goes to a, and noticing that the denominator goes to 0 as x goes to a, therefore the numerator must also go to 0 as x goes to a, because otherwise that limit would not exist. So if the numerator must go to 0, we could bring the f of a to the right-hand side, and we find that the limit as x goes to a of f of x is equal to f of a, which is simply the definition of continuity. We can ask, when are functions not differentiable? What are we looking for? What is not nice in functions that are not differentiable? Well, functions that are not differentiable will have corners, cusps, jumps, or vertical slope. An example is the curve of absolute value of x, which has a V shape, which has the corner. Let's just take a moment for some math culture. There was a mathematician who was convicted of a crime and was placed before a firing squad. The commander of the firing squad says, "I've heard that you've declined a last meal." "That's right," says the prisoner. "And you don't even want a last smoke or a blindfold." "No, let's just get it over with," says the mathematician. "Is there no last request we can grant you before we shoot you?" asked the commander. "Well," says the mathematician, "I'm a great lover of music, and it would mean a great deal to me if I'm allowed to sing my favorite song in its entirety before I am shot." "Since this wish of yours is your last request, I will grant it. You may sing," replies the commander. So the mathematician starts, 10 million bottles of beer on the wall, 10 million bottles of beer. Thank you for joining us today. Have a great day, and may the power of math be with you.